Oh, hello everybody. So I'm gone again. Oh, I caught somebody's crummy cold, but hopefully a good day of rest and I'll feel better. So hopefully you've looked at your journal, so I'm going to look at that as well with you. Today's date is Monday. It is 4/18. So our objective today is to talk about bisectors. Okay, bisectors. Well, what's bisector? A bisector is anything, when we say anything, we're talking about geometry things, anything that cuts something in half. Now that's the regular words for it, but then we'll use other words, we'll use more mathematical words as we do this, okay? So anything that cuts something in half. Well, we're going to start our geometry units. So we're on our fourth quarter. We've done a lot of algebra, a lot of problems. So finally we're going to do some geometry. So let's take a look. In our teacher's notes, hopefully you wrote this down, that a theorem is a math rule that can be proved, okay? So the perpendicular bisector theorem really is talking about if you have a bisector, that's this line segment here, PC, and if it cuts this segment in half. So we cut this in half, we bisected it at 90 degrees. What happens then in this triangle, it also will make these two sides equal. So it'll make AC equal to CB. Okay? And then the converse of that is just the opposite. Converse means opposite. So it says that if we have this occurring, that if these two sides are equal, and you have a line that comes through at 90 degrees, then you'll have these two have been bisected by the bisector. It's just when you hear the word converse in math, converse is the opposite statement, okay? So then you've got the angle bisector theorem, and hopefully you've written this down, and that is if an angle is bisected, so here's an angle that got cut in half, this angle got cut in half, then any point along here on the bisector is going to be equal distance to the sides if it's at 90 degrees, okay? And then the converse of that is just the opposite of what we just said. It's the opposite. So if this is equal distance from the two sides, then this has to be a bisector of the angle. Okay? So I can draw some pictures, you know, so if we perpendicular bisector theorem, if we have a line segment like this and it's bisected, okay, that means this side is equal to this side. It's bisected, right? Then these two sides would have to be equal if it's bisected at 90. Okay? Converse of that is just saying just the opposite, and it's saying if you have a line segment that happens to have these and it's at 90, that these two sides are equal, then it must be a bisector. It means it cuts this in half. So it's a bisector. Okay, now if we know that, then let's take a look at example 1. This is pretty easy. That's 10 and 10, okay? Well, we know that's 10 and 10. That's at 90. So here we know from our converse that, let me use my marker, we know from our converse if these two sides are equal and this bisector comes through at 90, then this side must be equal to this side. So we'll just solve. Now we're looking for the value of SU. All right, so SU is this length. Got back up. Here's what I know. I know this side is equal to this side. So let's set them equal. A little bit of algebra, 2x plus 2 is equal to 3x, okay? And if I find the value of x, that's going to be helpful. So I'm going to find the value of x. I'll go minus 2x, minus 2x. I'll get 2 equals 1x, or x is 2. Now that is not the answer. That's not the answer. What do you mean, Mr. Davies, that's not the answer? Well, what's the question? The question says find SU. Well, SU is this length right here. That's SU. So what do I have to do? Let's plug the 2 into the equation. I can do that. Find a pen. So I'm not done. Let's take the 2 and plug it into SU. So plug it in right in there. So let's see, SU is 2 times 2 plus 2, which is 4 plus 2. So SU must be 6. Pretty easy. I think you'll find this chapter is going to be so much easier than what we've been doing. At least I hope so. Okay, perpendicular bisector. Let's see what that means. So let's first graph. -3, 5, Okay, right there. There's A. Again, if I get going too fast, I'm trying to pace it, please ask the substitute to pause the video and you can get caught up. 1, -3, 1, 2, 3. There's a squeeze it way down here. B. B is way down here, okay? Alright, so let's draw this line segment. So let's find the equation of the perpendicular bisector to line segment. Okay, let's draw line segment AB. I'm just going to draw that in. Alright, good. So a line segment has a length. If it's got a length, it also should have a midpoint. So let's find the midpoint. Let's find the midpoint of AB. Alright. Let's see if I can do that. Well, I know it goes down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Let's see, I think the midpoint would have to be right there. Has to be right there. I can count it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. If I go down 8 over 4, then the middle of that would be half distance. Instead of down 8 over 4, I'd go down 4 over 2. So that's midpoint. Midpoint is at the point -1, 1. Okay, so that's my midpoint. It's at -1, 1. Okay, now, what I want is perpendicular. Perpendicular. So I found the midpoint. So let's see these words. Midpoint. Okay, midpoint, I found the middle. Okay, I've got that. Now, this word perpendicular means 90 degrees, right? Perpendicular means 90 degrees. So I want 90 degrees from here. So I want 90 degrees to be perpendicular. And to be 90 degrees, it's going to have the opposite slope. We've learned that before. Opposite slope. We've learned this. So let's see. What is the slope of AB? Well, I can count it. Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. So the slope of AB, is down 2 over 1. So then the opposite slope would be up 1 over 2. Alright, so let's go. Let's figure out what we have to do. Here's my line segment AB. I want to find a line that goes through the middle of it because it's a bisector, and I want it to be perpendicular at 90. Okay, so I found the middle so that I can bisect it. I have to do it at 90, so I found the slope of AB, and the opposite slope would make it 90, so -2 over 1 becomes 1 over 2. Okay, so from my point, up 1 over 2, because that's my opposite slope, up 1 over 2. Okay, so here is my line. Here's my bisector. I'm going to draw it in. That is my bisector. Well, if I'm looking for the equation, let's go back to what we've learned before, the equation of line. I would use y equals mx plus b. Okay, what we are trying to find is the equation of this red line. This red line is my bisector. It's a perpendicular bisector. I want the equation of this perpendicular bisector, so the answer's got to be y equals, let's see, it's up 1 over 2 x, because that's my slope, plus it goes through at 1.5. That is the equation to this line. So I'm going to back up. What did I do? Well, I made my line segment. I was looking for the bisector, so I found the middle of it. There's the midpoint of my line segment. I need to be perpendicular, so I knew it had to cross at 90 degrees. In order to cross at 90 degrees, I have to have opposite slopes. The slope of AB is down 2 over 1, down 2 over 1, down 2 over 1. So the opposite slope would be up 1 over 2. I drew my line through the midpoint and found its equation. Okay, I'm going to turn the page. Hopefully I'm not going too fast. Okay, all right. So the last one we talked about was this angle bisector theorem. So if we have an angle, and if it's bisected means it cut right in half. Okay, so this angle here is cut right in half, right? We know that any point along here is equal distance to the bisector. As long as it's at 90 degrees, that gives us the equal distance. Okay, so And of course the converse is just the opposite. So let's take a look at example 4. Here's what we know. We know it's an angle bisector. See, this is the way we see it. This little dash here and this here is one way in geometry we say that these two angles are equal. So if I'm going to write it out, we'll say, see that? That little dash, that little curvy is trying to say these two are equal. Okay, good. If the two angles are equal, and here it is 90, then these two sides must be equal, right? So I know these two sides are equal. All right, well, if they're equal, let's go ahead and set them equal to each other and solve. So I'm going to take my 3x plus 1, that's BD, equals my 5x minus 1, that's DC. And let's just solve for x. All right, I can do that. Minus 3x minus 3x. 1 is equal to a 2x minus 1, plus 1, plus 1. 2 is equal to 2x. Divide by 2, and x is equal to 1. Now that's not the answer, because what we're looking for is, what's the question? The question is find length of BD. So I'm going to take my 1, I'm going to plug it in for the x in BD, so I'll have 3 times 1 plus 1, which is 3 plus 1, so the value of BD is equal to 4. Alright, so that's all I have. I have a worksheet for you guys to do for homework. And this is the assignment right here. I want you to do all of them, and if you get done early, you can always work on your rocket. I hopefully will be back tomorrow, okay? I'll see ya. Bye.